Okay, class. So we're in part two of chapter 12 on the concept of capital investment decisions. And I'm just showing you here are the tables that you use for your calculations. And of course, you can always use your calculator, but the tables sometimes are useful because when you take an exam in either a CPA exam or a CMA exam, typically they'll give you tables, but not a calculator that does the calculations. However, for this class, of course, you can use your calculator. But just looking at the tables, first of all, we have the first one is table A is the present value of a dollar or the present value of a lump sum. Table B is the present value of annuity. So the first two are present value tables, and that's table B. Table C is the future value of a dollar, or of course lump sum. And you can see with the present value that it's much smaller than the future value. The future value is basically the principal plus the interest, whereas the present value is the principal minus whatever the interest is. Okay, so keep looking through. Table D then is the future value of annuity of a dollar. And again, annuity is an equal amount of money over a certain number of periods. And so if you look here, if you had an investment of $10,000 at 8%, and it's for 5 periods, you'd go down here to where it has 5 periods. And so the annuity factor for future value would be 5.867, which I put a line through. Okay, so just wanted to look at the tables so you had some reference point when we talk about it. Again, they use the tables for when you do exams. For your homework and other problems in this class, you can simply use your calculators. Okay, so back to the PowerPoint slides. We're looking at the future value and present value tables. And as we mentioned, and I have the page number, table A, present value of a dollar, lump sum. Table B, present value of annuity, and that again is an equal amount over a period of time, so $10,000 for 5 years, that would be an annuity. Future value of a dollar, that of course is the principal plus the interest, and we're always looking at it as compound interest. And then of course the future value of an annuity, which is in table D. Now, looking at a simple problem here, it says, what is the future value of $10,000 lump sum in 5 years? That would be, of course, table C. So we go 6%, go across the 6%, go down 5 rows, 6%, down 5 rows. Here's the present value, or the future value factor, I should say. So the future value is going to be equal to $13,380. Simple enough. The whole difficulty comes in reading the problem and make sure that you recognize, is it a present value or is it a future value? Is it a lump sum or is it an annuity? And then choose the table that it's appropriate. Here we go. We have a future value of investing $2,000 at the end of each year. Okay, so that's an annuity for 5 years. Table D, again, we're looking at 6%. We go 6% column, go across, go down 5 rows. Here's the present value, or I should say the future value of an annuity. Multiply this times 2,000 times the annuity future value factor, and it's 11,240. Okay, so that doesn't seem too difficult either. Again, recognize, is it future value or present value? And then you have to recognize, is it a lump sum, or in this case, is it an annuity? So just looking at a little bit of a visual image here, you can see that if you had $10,000 lump sum, you invested it at 6% for 5 years, you would end up having $13,380. If you took the same $10,000 but invested it $2,000 every year for 5 years, that's still $10,000 worth of an investment, but notice you'd have a lot less. And the reason is because you're earning interest on interest starting with a $10,000 amount versus 2,000 in this year, 2,000 in this year, 2,000 in this year. So in other words, the 10,000 you invested is not getting compound interest for every single year. Okay? Now, calculating the present value of single sums and annuities using the present value factors. If, for example, you won the lottery and you're looking at 3 different payouts. And this is how you would analyze exactly which payout you would choose. Do you want $1 million now? Do you want $150,000 at the end of each year for 10 years, which is 1.5 million? Or do you want $2 million 10 years from now? Well, this is just the present value of $1 million. So let's take a look at which alternative is better. If you got $1 million today, that's a present value of $1 million. $150,000 every year for 10 years is an annuity. That's the definition of an annuity. You would go and find the present value factor for 8% for 10 years, and that's 6.712, and that would give you a present value of $1,006,050. So what you're doing is you're actually discounting everything back to day 0. Or the third choice, which a lot of people might have taken, is $2 million, okay, at the end of 10 years, but the present value of a lump sum is 0.463, and so that would have only been worth $926,000. So you can see the choice you would make, given that you can earn 8%, I'm sorry, not 6%, but 8%, is if you took the $150,000 a year annuity rather than the $1 million today or $2 million in 10 years. Okay, so this just shows it in a different way of describing it. Same result. Now, how does this relate to what we're doing? Well, we're going to use present value when we talk about the net present value and the internal rate of return. So when we're talking about these two methods, remember, we're not going to use future values, we use present value. And of course, this goes back to the time value of money. In other words, interest earns interest, and the longer you have money invested, the more it's worth. So we're going to rely on the present value calculations to compare the cost of the initial investment with the expected cash inflows. Okay, so we're going to have a certain amount of inflows and a certain amount of outflows. So here's 2 potential investments. Both of them are going to cost $1 million and have a 5-year expected life. Okay, here's the net cash inflows. Okay, the cost is $1 million. Let's see what the present value of smartphones are compared to speakers. Okay, so the smartphone project generates $305,000 and $305,450 of net cash inflows every year for 5 years. So we know that's the present value of an annuity from table B. We expect 14% interest on this particular investment for 5 years. So we go across 14% down 5. Here's the present value factor. And so the present value of these cash inflows will be $1,048,610 minus the $1 million investment. And so our net present value is $48,610. Now, that doesn't mean we earned $48,610. That means that we earned more than the 14%, which was the annuity present value factor. Okay, we earned more than 14% on this particular investment. So the decision is, when you invest in a capital asset, if the NPV, the net present value, is positive, you invest. If the net present value is negative, you do not invest. And what it basically tells you is, did you earn more than the desired interest rate, or did you earn less than it? So what if you have an unequal annual net cash inflow? So here we're going to get 500,000 the first year, 350 the second, 300,000 the third, and then 250 in the fourth and 40,000 in the fifth. So this is a series of lump sum, and it's not an annuity because they're not the same amount. So we're going to have to set up a table that has the present value of $1 for each year. So you can see it's still 14%, but we're going to get an unequal amount of money. So it is not a net present value of an annuity. It's the net present value of 5 different lump sums. So here are the factors. Here's the amount of the cash inflow. We add this up as the present value of all of the cash inflows. We subtract the net cash outflow, or the investment of $1 million, and this gives us a net present value of $78,910. So we earned more in this investment than we did in the prior one. How much? We can calculate how much comparing the two amounts, but we know that we made more than 14%. Now, sometimes you have a number of alternative projects, so you use something called the profitability index. And this is going to compute the number of dollars returned for every dollar investment. And it's a way of comparing unequal amounts of investments. So if you have projects A, B, and C, all you have to do is take the amount of the cash inflows divided by the amount of the cash outflows. So that would be 150 divided by the initial investment. And this gives you a profitability index. Okay, so this one here, 1.2. If we take a look at project B, it's 238 divided by 200. That's 1.19. And the last one is 182,000 divided by 150. And so our profitability index says that we should take project C as our first project, and then project A, and then project B. All right, now sometimes when you do problems, you have residual value. So even if you have an annuity, you do the present value of the annuity. Remember, you have to do also a discounted present value of the lump sum for the residual value. So it says, suppose this smartphone project has equipment that'll be worth $100,000 at the end of the useful life. Now, what's the net present value of the project? Well, you can see that what we had to do, because this is the one that had the least amount, is we still have the present value of the annuity here, but now we're going to take the present value of the $100,000 in year 5 at 14%. So there's the present value of a lump sum, and we're going to add that to the present value of the annuity, and now this becomes the preferred investment. Okay, now we're going to choose the smartphones as the investment because we know it's over 14%, and we know that the net present value is greater than the alternative. Okay, now the last one is the internal rate of return, and that gives you an idea of what is that percentage that you're actually getting when you invest. And it's based on the discounted cash flows where the interest rate makes the net present value equal to zero. That'll tell you what the internal rate of return is. The interest rate that makes the cost of the investment equal the present value of the cash inflows is the internal rate of return. And the higher it is, the more desirable the project. Now, the easiest way to do this, I got to tell you up front, is an Excel spreadsheet, or if you use a calculator, almost any calculator will give you the IRR. But if you're using the tables, again, if you have to take a test, then you're going to take the initial investment divided by the amount of each net cash inflow to get the annuity present value factor. In other words, this is going to be an annuity. So you calculate this annuity present factor, use the present value of the annuity, in other words, table B, go on the row that corresponds to the useful life. So if this has a useful life of 5 years, you go down 5 years, and then you go across, and you see approximately the number that is the present value of the annuity, and it'll show you what the percentage is. Okay, so something like this, we have an initial investment of $1 million that goes here. Here's our cash inflows of $305,450. Here's the annuity present value factor. Okay, so we went down 5 rows. This is in table B, okay? And then we went across, and when we went across, this 3.274 was closest to 16%. Now, because we still had a positive number here, we knew it wasn't exactly 16%. We knew it had to be a little bit higher than that. Okay, so we went over to 18%. We tried to see, well, what would the present value be at 18%? And see, now it's almost zero. So to answer the question, the internal rate of return is going to be between 18%, and because this is still positive, and 20%, but it's going to be much closer to 18%. Okay, so this just gave me a beginning point. Now you can interpolate this so that you get the exact number, but again, just use your calculator. All right, so capital budgeting methods. Payback period is very simple, focuses on the time it takes to recover the company's cash investment. It ignores any cash flows after the payback period, so that's the key. It doesn't look, it could be 10 years or 2 years, but it counts the same. It highlights the risk of investments with longer cash recovery periods, and it totally ignores the time value of money. The accounting rate of return is the only method that focuses on the accrual basis of accounting because we look at operating income and not cash flows. Shows the impact of an investment on operating income. It measures the average profitability of the asset over its entire life. So we'd like to know how much, return are we having on a specific asset. It also ignores the time value of money. And then, of course, we have the last two, which are more sophisticated methods. And a lot of times we'll use payback and accounting rate of return as kind of screening. And then the detailed ones come from net present value and internal rate of returns. They both use the time value of money. This one indicates whether the asset will earn the company's minimum required rate of return. So again, if you have a 12% minimum required rate of return, the NPV must be positive, okay? Shows the excess or deficiency of the present value. And the profitability index should be computed for capital rationing. So if you can't do all of the projects, set up a profitability index to determine which one is the best of the different investments. Internal rate of return is going to compute the project's unique rate of return. So it's going to give you the interest rate for that project. There's no additional steps needed for capital rationing because you simply would take whatever has the highest internal rate of return. In other words, 15% is greater than 14%. Okay, class, that's it. Good luck, and thank you for taking my class.